So where are you at in calculus? How far have you gotten?
Today we got to the exponent rule and she showed us how to do it if we divided.
The exponent rule. You mean the power rule?
Oh yeah, it's a power rule.
Okay, so if I had this, what's the first derivative of it?
3x squared.
Okay, that's the power rule. Okay? And you can use the power rule whenever you have a simple polynomial. Or even if I have a polynomial that is made up of a bunch of things, like I can take the power rule on that one, and it becomes 3x squared. I can apply the power rule there, that becomes 4x, and that becomes that. So the power rule is extremely effective if you have a simple polynomial. Certainly easier than applying the limit definition derivative. What else? Have you gotten to the derivatives of sine and cosine?
No, we haven't done it.
Okay. You will get that very shortly. I might as well give it to you here. If y equals sine x, then y prime, the derivative of sine, is cosine. If y equals cosine x, the derivative of cosine is negative sine. So those two things you want to memorize right there. Alright, so let's see, what should we work on? If you've just gotten to the power rule, then you're still on 2.2, section 2.2, correct?
I guess she doesn't really use the book in her lesson.
Okay. Okay. Let's talk about finding the equation of a tangent line. That's kind of the most basic thing you can do with derivatives. If f of x equals x squared, what is the equation? Well, first of all, let me graph that. It's parabola, vertex at 0, 0. What is the equation of the tangent line when x equal minus 2? In other words, what's the equation of that line? This is y equal x squared. So let's talk about how we're going to find the equation of that line. What's the most important part of the equation of any line?
Slope.
Okay. What is the slope of this thing when x is equal to minus 2?
Negative 4.
So it's the first derivative evaluated at minus 2, which indeed is equal to minus 4. So my slope equals minus 4. Well, how do I come up with the equation of a line whose slope is minus 4 and it goes through this point? X equals minus 2. Well, what's the full point?
It's negative 2, 4.
So that's the point that it really goes through. In other words, that's this point right here, negative 2, 4. Well, if you have a point and you have a slope, what is the definition of the equation of that line? I have point slope. What format should I use?
Point slope.
Okay, what's the point slope format? General.
Y minus, or y, I guess, minus y, or x equals, and
Okay, there's my general equation for the equation of a line. So I know what my slope is. I know what my x and y points are. Fill in everything here.
y minus 4 equals negative 4 times x plus 2.
What is m?
Negative 4.
Okay, and that's the answer actually. In other words, there's no need to simplify that. They didn't say, give me the equation in slope-intercept format. If they don't specify, then the easiest thing to do is give it in point-slope format. What's the equation of the normal line? In other words, if I go up here and I write a line perpendicular to that line, what's the equation of this line?
Y minus 4.
Having a little hard time hearing you, Saad. Your voice tends to drift away sometimes, like you're getting further away from the microphone.
Y minus 4 equals 1/4 times x plus 2.
Good. In other words, it goes through the same point. The only difference in this line at all is it has a different slope. It has a slope of 1/4, positive 1/4. All right. Now, probably the key point in solving that first problem, because they only told us that y was equal to minus, or x was minus 2. They didn't give us the y value. So the first thing we had to do was plug in the x value of minus 2 to figure out that y was 4. Because they didn't give us that. They merely said, and that's frequently the case. In other words, if I said f of x equals x to the 4th, yeah, never mind. You understand what I mean. All right, let's go forward. How do I do this one? Y equals 2 over x. How do I apply the power rule to that to find y prime?
You bring the x to the top by making x to the negative 1.
And what's y prime?
So it would be negative 2 over x squared.
Okay. Let's talk about the product rule, which is the next rule you're going to get, I believe. Yeah, they give you trig functions, and then let's back up and talk about position and velocity and acceleration. Okay?
Okay.
If we have a diver who jumps off of a diving board that is 32 feet above the water, the position of the diver, and when you're talking position functions, we frequently use S. And it's usually a t because it's going to be a factor of time. This is the position function at any point in time. You can tell where the diver is. Notice that at time equals 0, the diver is 32 feet high. He's 32 feet above the water. At 1 second, he's going to be only 16 feet above the water. Hold it. Wow. Well, let's go on. You've probably been taught that velocity is the first derivative of position, right?
Yeah.
So what is v of t? In other words, v of t is the first derivative of s of t. So apply the power rule. Let's come up with v of t.
Negative 32 plus 16.
Yeah, and that's going to tell you your velocity at any point in time. In other words, when he leaps at t equals 0, his velocity is going to be 16 feet per second. When does the diver hit the water? What's his velocity when he hits the water? Well, first of all, hold on. Let me go backwards. Now, let's back up. What's his height when he hits the water?
0.
Okay, so we want to let that equal 0 and solve this quadratic. That will tell us what time he hits the water, because his position will have gone from 32 feet above the water to 0 feet above the water. Okay, and this thing factors nicely. So if that's equal to 0, then what time does he hit the water? I got two solutions. Are both of them valid?
Negative 1 is it.
No, you can't have negative times. Okay, so this tells us that 2 seconds after he jumps, he hits the water. Okay, now we know what the velocity function is. It's that. So what is his velocity when he hits the water? I know that he hits the water when t equals 2. So what is v of 2?
48.
Minus 48.
Yeah.
And that's because he's going down. In other words, with velocities, down is negative, up is positive, to the right is positive, to the left is negative. Okay? And that's helpful. In other words, we've used differentiation to figure out what his velocity is when he hits the water, and that's the only way to do it, without differentiation. And let's talk about one other thing, and that is acceleration. In other words, v of t is equal to the first derivative of position a of t, acceleration, is equal to the first derivative of velocity. So you have position, and then its first derivative is velocity, and its second derivative is acceleration. So when you're talking acceleration, you're always talking about the second derivative of position. Let's get into the product rule. Even though you haven't had it, I'll give you a little heads up on it. It's not as simple as you think. In other words, if y is equal to x sine of x, I'm multiplying two things together. I'm multiplying x times sine of x. Or you could say u times a different function v. Well, y prime, the product rule, is always the first function times the derivative of the second function plus the reverse. Simple as that. Product rule is one of the simpler rules. But, so let's apply it to this problem. What is y prime going to be?
It's going to be x times cosine x plus 1 cosine x.
1 times sine x. In other words, this is this times the derivative of that plus the reverse. The derivative of x, which is 1, times the original, sine x. With me?
Yeah.
Okay. So let's find the derivative of this. Now there's a couple ways I could go here. I could go ahead and multiply those two out, come up with a single polynomial, and then just use the power rule. But let's do it using the product rule. So what is h prime of x equal to?
3x minus 2x squared times 4 plus 3 minus 4x times 5 plus 4x.
Good. Now, in this case, I had an alternative way I could have done it. I could have multiplied those two polynomials together, and I would have ended up with the same answer. Okay? If I have a combination of a trig function, I can't do that. In other words, if I have g of x equals x sine x, I can't multiply those two together. They're different kinds of functions. One's a polynomial, the other is a transcendental function, a trig function. So the only way I can get g prime of x is by using the product rule. X times cosine of x plus 1 times sine x. And obviously you can reverse these. So it doesn't matter whether I put that first or that first. The way to remember it is obviously it's one function times the derivative of the other plus the reverse. That's kind of the way I remember it. Okay, let's do another one. What's y prime?
The 2 sine x.
Don't take the derivative of both.
Oh, 2x sine x, or negative sine x.
Okay. Plus what?
Plus 2 cosine x.
Now what about that part there? In other words, you just did this part.
Minus cosine x.
In other words, you don't have, if one of the things being multiplied is just a number, you don't have to use the product rule. The derivative of 2 sine x is 2 cosine x. Okay? And now, of course, that cancels with that, and you're left with minus 2x sine x. Okay, product rule is pretty easy. So let's talk about the quotient rule. Quotient rule is a little harder to memorize. Let's assume that I'm dividing y by v, or u by v, and if I want y prime, this one I have a way of memorizing it, and this one is difficult to memorize. I'll show you why. It's the bottom times the derivative of the top, and it's minus, which means the order matters. The reverse, which is the derivative of the bottom times the top, all divided by the bottom squared. So the way I remember the quotient rule is you begin with the bottom and you end with the bottom squared. And if you remember those two statements, you'll always get it, because if you begin with the bottom, the next thing is going to be the derivative of the top. And since order matters, I must be subtracting, not adding. And this piece here has to be the opposite of that, so it's got to be v prime u, and the bottom square. So the only thing I have to remember when I'm trying to remember the quotient rule is begin with the bottom, end with the bottom squared. Okay?
Okay.
Let's apply it. Y equals 5x minus 2 all over x squared plus 1. All right. I'll leave it up there for the moment. What is y prime equal to?
X squared plus times
Hold it. Say again.
x squared plus 1 times 5x.
In parentheses.
Yeah.
Times, what is u prime? What's the top? What's the derivative of the top?
5x.
Just 5.
I mean, yeah, 5.
Just 5. Okay. Now minus.
Minus 2x times 5x minus 2. All over x squared plus 2.
Yeah, and that's the way you want to write that. In other words, you don't really want to square that out and put x to the fourth. Okay? So that's the way you do the derivative whenever you have the quotient. And again, notice we couldn't do that division. So I had no way of simplifying that. So I had to use the quotient rule to take the derivative of it. Now, I have a different way I could do it. I could do it using the limit definition rule, but that way is always harder than these rules. In other words, once you learn the power rule, the product rule, the quotient rule, and there's only one more, the chain rule, then you can differentiate any function or any combinations of functions. It's the derivative of this.
Cosine x times cosine x minus negative sine x times times sine x all over cos x squared.
Cosine squared of x. In other words, there is a difference. Cosine squared of x is not the same as cosine of x squared. This means cosine x times cosine x, whereas if I put the 2 over here, then I would be squaring the x and just taking the cosine of it. Okay?
If you did cosine x in parentheses, then put the squared outside of that, okay?
Didn't hear exactly what you said. What?
If you put the cosine x in parentheses and then square the whole parentheses,
that's the same as this. Yes. In other words, if I do this, that's the same as this. But it is not the same as this. And that's true with all trig functions. Okay. So, I ended up here with cosine x times cosine x, that's cosine squared x. These two negatives become a positive, plus sine squared x, all over cosine squared x. What is cosine plus sine? What's cosine squared plus sine squared?
1.
So I can replace that with the number 1. And now I have 1 over cosine squared x, which is secant squared x. So the derivative of sine over cosine, which you'll notice is the same as tangent. So the derivative of tangent is secant squared x. At some point, they're going to want you to memorize the derivatives of all 6 trig functions. So let's just go through them. If this is y and this is y prime, okay, sine is cosine. Cosine is minus sine. Tangent is secant squared. Cotangent is negative cosecant squared. The derivative of secant is secant tangent. And the derivative of cosecant is negative cosecant cotangent. Now that might seem hard to remember, but notice that if you look at the 3 cofunctions, the derivative of the cofunction is negative in each case. In other words, cosine is the cofunction of sine, and that is the cofunction of that, only with a negative. And all of them are like that. In other words, when I take the derivative of tangent, I get secant squared. Well, the derivative of cotangent is going to be negative, first of all, and it's going to be whatever the cofunction of that is. Because that's the cofunction of that, then the derivative of cotangent is minus cosecant squared. Same with secant. If the derivative of secant is secant times tangent, then the derivative of cosecant, its cofunction, is negative the cofunction of secant or cosecant times cotangent. So there's kind of a pattern here. The only ones you really have to remember are those three, because the cofunction is just the negative sign and the cofunction of this. In other words, this is the cofunction of that, that's the cofunction of that, and that is both the cofunctions of those two. All right, let's do a slightly harder one. We want f prime of x.
X plus 5.
I'm sorry, what?
X plus 5 times.
Okay,
Negative.
no, you got the right idea. You're applying the quotient rule. But there's something that we can do to simplify this a little bit first. In other words, we don't like having a fraction in our numerator like that. So let's multiply top and bottom by x. I'm going to multiply the whole top by x. I'm going to multiply the whole bottom by x. Is all I'm doing is multiplying that fraction by the number 1. Which turns it into 3x minus 1 over x squared plus 5x. Now this is easier to deal with than this was. So let's start from there and come up with f prime of x.
X squared plus 5x times 3 minus 2x plus 5 times 3x.
And be very careful here that you use parentheses.
Okay. Yeah.
Because if you don't, you're going to come up with the wrong answer. Okay, so that's the new numerator. What's the denominator?
It'd be x squared plus 5x squared in parentheses, and that's all squared.
Yeah, and you don't need to expand that. However, you do need to simplify this whole thing. In other words, we've got stuff in the numerator that I can simplify. So, and you almost always can whenever you've applied the quotient rule, is you're always going to end up with something that needs simplified. Okay? So let's simplify this top.
3x squared plus 15x.
Minus, and then now you're going to have to FOIL these two things.
6x squared. Well, minus 2x.
I'm sorry, what?
Minus 2x
Okay.
plus 15x.
Okay, we still have this thing in the bottom here. Now remove the brackets and combine like terms in the numerator.
Okay, would be negative 3x squared minus, so plus 2.
Plus 2x?
Yeah, plus 2x. And
in other words, this 15x cancels with that 15x. You see why? In other words, this minus sign has to be distributed to every term there. But we still do have a plus 2x. Okay, and what's the number we're left with?
Plus 5.
And that's the answer. And we rarely multiply out that bottom. In other words, I can't do anything with it if I were to multiply it out. So I don't do it. And that ends up being the answer. So if I said, let's change this problem slightly and say, what is the equation of the tangent line at the point -1, 1? So this is the first derivative of the function, and they want the equation of the tangent line at that point. What's the slope of the tangent line?
Isn't it 0? So 0.
Yes, 0 over whatever, right? In other words, you plugged in -1 for x, and you got 0 in the numerator. So I don't really care what the denominator is. My slope of the tangent line is 0, horizontal. Correct?
Yeah.
In other words, I could plug in -1 in the bottom, but I don't need to. Whatever number I come up with, my slope is still going to be 0. So now, come up with the equation of the tangent line. If my slope is 0.
1.
Y equal what?
1. Oh, you want the equation?
Yeah.
Okay.
Well, no, that you actually got it. In other words, if I'm going to say y equal mx plus b, and slope is 0, then this term goes away, and I've got y equal b. Well, the y-intercept has to be 1, because it's a horizontal line. So it's just y equal 1 is the equation of that tangent line. And just to show you a picture, if I were graphing that particular function, its graph looks something like, let's see, I got asymptotes there, and I got asymptotes here, and the graph looks something like this. Well, when I said, what's the slope at the point -1, 1? Well, there's -1, and you can see that the slope is horizontal. When we took the first derivative and evaluated it at x equal -1, we got 0. And that's what we should have got. Okay. Now, not every quotient needs to be differentiated by the quotient rule. Notice that if I said, what is the derivative of this? You could use the quotient rule if you wanted, But it's much easier to write that way, and now you just use the product rule. Y prime equals minus 6x to the minus third, or minus 6 over x to the third. So sometimes the quotient rule is definitely not the fastest way to do something. If you can turn a quotient into a non-quotient easily, then it's probably faster to just use the power rule. Even problems something like this. How would you find y prime? Do I have to use the quotient rule?
You could most
Best thing to do is just separate that thing into two polynomials. Like that. And now just use the power rule on each one. What's the derivative of this?
2x.
Remember what this is that's the same as 1/6 x squared plus 1/2 x. That's what these two things are. So now you use the power rule on that. What do you get?
2x over 6.
Or 1/3 x. And what do you get when you apply the power rule on that?
1/2.
So it was much easier doing that than it was trying to apply the quotient rule to that. So I guess the rule is don't use the quotient rule unless you really have to. If you can simplify the function first, then you might be able to get away without using the quotient rule. You'll get the same answer, but it'll be a lot harder if you use the quotient rule. Okay, hold on. I'm just kind of going through the book here. Let's do this one. It's y prime. And incidentally, let's talk just for a moment about notation. There are a lot of ways of saying the first derivative. I can say y prime. I can say f prime of x. I can say dy dx. I can say delta y over delta x. All of those mean the same thing. That means the same as that, the same as that, the same as that. Why do they have so many different ways of saying the same thing? Well, this is a little more robust. If I just say y prime, I don't tell you what I'm taking the derivative relative to. And it's very important that I take the derivative relative to x. So I like this notation the best, because that tells me I am taking dy relative to dx. I'm not taking dy relative to t or r. I'm taking it relative to x. That denominator is very important. If I told you that y was equal to that, and I said, what is dy dt? Well, now I got a whole different problem. I can't take dy dt directly, because I don't have a function of t. We can do it, but that's the next thing you're going to learn in differentiation, is what happens when this denominator is not the variable that you need it to be. Then you use something called the chain rule, and that's the last rule you have to know. There's only 4 rules you need to know to differentiate any function. That's the power rule, product rule, quotient rule, and chain rule. We haven't talked about the chain rule yet. It's a little harder. But let's just find first derivative of this.
Should be 1 minus secant squared x.
There you go. Simple as that. And we'll make it a little harder. Now you got to use the product rule because we have the product of two things that we cannot multiply together. And simplify. Okay, well, I didn't hear the first part. What?
X times secant x tan x. Is it plus or plus 1 or it would be secant x and or no, just secant.
Just that. In other words, for the second part of using the product, we're just going to take the derivative of that times that. The first part, we took this times the derivative of this. For the second part, we always do the reverse. Okay, you don't want to take the derivative of secant again. And we don't need the 1. So there's the answer. All right, I think that's probably a good place to stop. And you'll either have the chain rule by the next time we meet, or we'll talk about it. And the chain rule is very critical. Okay?
Okay.
Saad, have a good week, and I will talk to you next Friday at the same time.
You too.
All right, bye-bye.